はい、ドイツの方からホフマンさんにお話しいただきました。今ホフマンさんがキックスタディというふうにおっしゃっていたんですが、KIKK スタディ、調査ですね、といったもので、平常時、稼働しているところの原子力発電所の周りの子どもたちの調査をドイツはしていったといったところで、KIKK 調査なんですけれども、日本の方は私たちKKK 調査と呼んでいます。これは福島の県民健康管理調査なので、これで KKK 調査と呼んでいるんですけれども、はい、ドイツの方は、KIKK 調査をやっていて、その今の状況を伺いました。でも日本の方の KKK 調査はどうであるのかといったところで大きな問題点はあると思います。私の方ではですね、実は今日は夢だったんですが、ドイツの放射線ドイツの方の疫学協会の会長のホフマンさんにいらっしゃっていただきまして、日本の方の疫学者に来ていただきたいというところでお探ししまして、白羽の矢を立てましたのが、水俣病の調査をなさっていらっしゃって、そして現在は双葉の方での調査をなさっていらっしゃる岡山大学の、津田さんです。津田さんの方でお話をいただきたいと思います。まず皆様の方にですね、配布資料で津田さんの方の配布資料がたくさんあるんですね。というのが私たちの方から津田さんにあれもこれも
We requested many different questions and documentations from Professor Tsuda, and that is why he has presented 4 different PowerPoint presentations. However, because the time will be limited for Dr. Tsuda to make the presentation, he will be only using the presentation 1, 2, and 3, and he will be focusing on the KKK studies in Fukushima Prefecture for the possibility of thyroid cancer in Fukushima for under 19. He will be focusing on this topic, but regarding epidemiological study, there are many unknown areas and difficulties to understand the data. So one request we have made was to first explain what epidemiology is all about. And that is why he has one handout, page 7 of the presentation, the handout materials. It's a reference material. He will talk about that first and then go into his presentation. Thank you. It is nice to meet you. My name is Tsuda. I have been serving as a doctor, a medical doctor. And I have been specializing in the troc area and study in the polluted area. So therefore I have been working on the public pollution issues in terms of my PhD studies. So that is why environmental medicine was also one area of my expertise. We observe population in humans, and that is why my specialty is within the field of epidemiology. In 1990s, there were many cases of food poisoning in Japan, and food poisoning can also be covered within epidemiology in terms of the food stuff that could cause the food poisoning, and that food poisoning is declared through a study of epidemiology. This is also called the outbreak epidemiology. So this is an ongoing epidemiology where the outbreak is currently occurring, and you study that incidence and that phenomena as it is ongoing. And I have, since my past experience in these areas, were extremely useful in applying to the Fukushima disasters. Regarding the food poisoning outbreak epidemiology, we have been studying that and working together with the administrative staff from Okayama Prefecture and other prefectures in Shimane, in the nearby prefecture from Okayama. But after 15 years, we have many more participants going all the way from the Hokkaido in north. So in that sense, our research has expanded, and every year we undertake also a study session on the food poisoning epidemiological studies. And in that sense, we always make requests and point out issues with the to the government, public officials. But in a way, we are always in dialogue with the public officials and members of the government in these areas. So we have some textbooks, references of food poisoning epidemiology. And one particular area within it is how to deal with the media and public relations. Public relations in times of outbreak of epidemics need to be undertaken very properly, because otherwise we would be focusing too much on the public relations issues and to neglect what we are supposed to do. In case of outbreak, what we need to do is to find out the cause as soon as possible and minimize the human damage, and also minimize economic damage as well. And in that sense, if we forget these ultimate objectives, the public servants, member of the government, will be lost at a loss. And the situation of what happened in Fukushima Prefecture and the Fukushima nuclear power plant really is the lessons of what we should avoid. And in fact, we have made this book which assembles all the things that was done wrongly, what was not right about the responses of the government in the Fukushima Prefecture. This is available, and this is a very good lesson. This is written by a journalist, and I hope that the members of the government would be reading this textbook as a lesson of what to avoid in the future in a similar incidences. So therefore, what I'd like to cover today is the epidemiology and outbreak, and why we have to analyze the outbreak or multiple occurrences other than in order to avoid the outbreak. What most people are curious is this topic, the precise topic that we would like to talk about. And in terms of if there is an outbreak or multiple occurrences, we need to determine the scope and the area, the degree of multiple occurrences, high incident, in order to prepare. And the third reason why we need to study this is regarding the air dose. The iode 137 and air dose is very much interlinked. The iode has a half-life of about 8 days, so therefore it is too late now to talk about evacuation or other countermeasures. However, when we talk about the air dose, this is still under the scope, and in that sense, to obtain and qualitatively the indicator that would be the third reason why we need to study this. And the fourth reason is the following. We call it biological monitoring. The child thyroid cancer is a very rare disease, and so therefore when there are many confusion, as in the case of Fukushima, and when there are many contradicting information about the radiation level, by counting the actual cases of pediatric thyroid cancer, we will be able to understand the past history. It is in a way an indicator of understanding the past radiation level. So that is also an additional objective of reason why we undertake this study. So with that in mind, I'd like to continue my presentation. But before that, I'd like to talk about a topic which is how to read epidemiological data.
まあ食中毒なんでも因果関係は問題になるわけですね。ところが因果関係は直接観察できないわけです。
In case of food poisoning, the causal relationship is not an issue. But however, causal relationship cannot be observed directly. If there is an, for example, exposure to radiation, that would be the cause. But that cause cannot be directly observed. It can only be known to a certain extent. The outcome is clear. That would be an outcome, for example, of disease, and that could be known. But in between that cause and the outcome is an unknown area that cannot be known directly. It cannot be seen, it's inaudible, it doesn't tasteless, it's odorless, and it's not tangible. And so maybe sixth sense would be the answer. Well, that is not the case. And so therefore we need to express this causal relationship with figures and with words, and that is what epidemiology is all about. In order to make the epidemiological relationship visible, the causal relationship visible, we have such equation. The denominator of the numerator would be the number of exposed patients. The denominator of the numerator would be the number of exposed population multiplied by the time spent under the exposure. As for the denominator of the denominator, it's the number of unexposed patients, and the denominator of the denominator would be the number of unexposed population multiplied by time spent in the unexposed. So this would be able to calculate the actual degrees of multiple occurrences or high incidence. SIR and RR and OE ratio as well as O2 ratio were mentioned by Dr. Hoffman in his presentation. All this has to do with a similar type of equation to understand the causal relation. We call it IRR in my presentation. It's the incident rate ratio, which is the incident rate of the exposed divided by the incident rate of the unexposed. So in a qualitative scientific study, there is always a probability denominator. So and we always have the 95% CI or confidence indicator or confidence level, and that is something that Dr. Hoffman covered. The confidence interval, excuse me. The causal relationship as such can be explained in terms of incident rate ratio. So greater the exposure, would it be the case that there will be higher incidence rate? And in that sense, there is dose response relationship. With more information and with the more time passed and with more people observing, it is possible to make the assumptions more accurate, which is not the case today, because now we only have new additional information that are inputted every 3 months or so. In this year's international conference on the radiation medicine, well, I was there and I made a presentation at that time. I'd like to continue my presentation using this slide. Epidemic curve of thyroid cancer in Chernobyl under the 15 years old. You can see here that the accident occurred in the latter half of April 1986 in Chernobyl. And if we put the Fukushima incidence in this time frame, it would be here. we would be here. In case of Chernobyl, we have seen suddenly the fourth year in the 1990 the increase of incidence of thyroid cancer. The number of patients suddenly increased after the fourth year and beyond. But in case of Fukushima, we are only here 2 years after. But if you look carefully, you could see that there is a minimal and a gradual increase even in this first 2 to 3 years. And the situation is quite different from pre-accident time. If this is what is happening in case of Fukushima, in 2 years' time in Fukushima, we could maybe expect an outbreak. And that is why we are, with that in mind as a possibility, we are undertaking measurement now. So if that outbreak could be a possibility in the future, we would be it would be wise for us to undertake constructive discussion and make preparation for a possible outbreak in the future. And you are more of an expert about these pages, so I'll be very brief. The March 11th earthquake and tsunami caused the Fukushima Daiichi plant accident. This is the time of the occurrence of the earthquake, and this is the fluctuations and trends of the air dose radiation. There was a massive release of radioactive material into the air at that point. And Dr. Hayakawa from Gunma University has released this information. I obtained that from the internet. This is the flow of plume after March 11th, 2011. In the morning of March 15th, the plume looked like this. And on the 15th March afternoon, we have seen this kind of formation of plume and the movement of plume, which determines the air dose today in various areas. This page summarizes the plume situation after March 11th, 2011. As you already might know, after the accident, the primary screening took place, followed up by a follow-up secondary examination. So the primary examination is a very brief examination using echo ultrasound of the thyroid of all residents under 19. It took place in 2011. If there is a node that is more than 5 millimeters in diameter or cyst of more than 20 millimeters, then there will be a follow-up examination. Followed by ultrasound and then cytology if needed, if they do find some cancer cells. This schedule is a 3-year cycle currently. This is the map of air dose rate as of February 1st, 2013. Depending on the air dose level in various regions, the thyroid examination will be undertaken, and the priority is set as initial year, second year, and third year. So there are 3 areas. The reason why Iwamishi, which is in the bottom part, will have the least priority in terms of the order of examination is because their air dose level is low. By the way, the population density of Fukushima is about 3 times higher than that of the Belarus. Now, in terms of methodology, this is released and available on the internet of the National Cancer Center as well. Age, sex-specific incidence estimate of thyroid cancer from the Center of Cancer Control and Information Services used. But there are some criticism that this data is not an appropriate data to be used in terms of comparison. But with more information, the accuracy of this information will not be as important. And looking at this past data, we can say that the Japanese mean annual incidence of the people aged 15-19 in thyroid cancer from 1975 to 2008 is only 5 per 1 million. In case of Fukushima, there is a release of new data of the examination every 3 months or so, and this afternoon we are expecting the latest result release as well. Now, in terms of methodologies, only available data from the previous explained methodology is prevalence, but then there is also the incidence. The relationship between the prevalence and the incidence is as you can see here. By multiplying incidence with the average duration, you can obtain prevalence. But you can vary the average duration of prevalence. So the average duration is defined here as when it is possible to detect thyroid cancer from cytology by needle aspiration. Up until the point where it is visible from clinical examination alone that there is thyroid cancer. Now the result number 1 is as such. We have the first year result so far only of the nearest areas to the Fukushima Daiichi plant, and we have the mid-range area including Fukushima City and also Okayama area as well. This is the result of the first examination. Now, we have subdivided the moderate area or mid-range area to 4 different areas: Fukushima City, Nihonmatsu, Motomiya, and the rest. And the second column shows the population of under 18. And the result, number 3, looks like this. So IRR is 31.48 if the prevalence duration is 2 years. In case of 4 years, it would be 15.74. And that would be the figure if there is, if the denominator is 5 in every 1 million. If in case of 11 in every million, the figures will be slightly different, as you can see on the right-hand side. So in exact same area, we obtained 4 different figures of estimates of IRR. This is a result for the mid-range area, moderate near area. Motomiyachi is the closest, and the second comes Nihonmatsu, and then Fukushima, and the rest. That's in terms of distance from the nuclear power plant, and it also coincides with the air dose level of these 4 areas. Every time there is new data, we will be making recalculations. And higher the IRR, or if the air dose level, or if the radioactive iode background level is in line with this figure, it would mean that the causal relationship between the March 11th nuclear power plant disaster would be clear. And actually the a significant difference is quite clear. So the statistical significance is quite clear already today. The conclusion so far, in the interim conclusion, would be that in case of Chernobyl, after 4 years after the accident, we have a clear outbreak of thyroid cancer, but then the gradual increase in incidences started appearing in the 1 or 2 years after that accident. And this is not only the case of Ukraine or Belarus, but it also was observed in Ukraine as well. So wider the area, the scope area, clear it becomes. If the target area is very narrow, it is not obvious to see this trend. In case of Fukushima, this is as the cases as I explained before. Now, to continue with the interim conclusion, we also have to take into consideration the screening effects as well when we look at the situation. So in that sense, if there is a possibility of outcome in the future, then we need to make necessary preparations. We need to look at the possibility of screening effects and also at actual effects. And I would say that there is both. And in any case, what kind of preparation do we need to undertake now? And my final presentation page is warning. This is a data provided by Dr. Imanaga for Belarus. This is on the left-hand side. You see the trends in the pediatric thyroid cancer in Belarus. On the right-hand side, you see the thyroid cancer in adults in Belarus. But you can see that the actual target population is completely different. In case of adults, there are 10-fold more target population in the study. So in terms of the population, there are many more incidences of adult thyroid cancer compared to a pediatric thyroid cancer, but there has not been any discussion about this fact. So therefore, this is something that needs to be revised. In terms of the probability, of course, the pediatric thyroid cancer is greater. In terms of the in terms of the increase, there is a greater increase for the pediatric cancer. But in terms of the absolute number of patients and incidences, adult thyroid cancer is much greater. And these absolute numbers and cases has impact in terms of the resource that we can use in terms of medical analysis. And the concern is also about the capacity of hospitals, for example. In case of Fukushima, we are looking for the new data on thyroid cancer in this month or next month. Fukushima Prefecture will be releasing the latest figure, and we are looking with interest what will be the changes in the figures. Thank you very much for your attention. Thank you very much, Professor Tsuda. The KKK study was mentioned by Professor Tsuda. On the 21st of December, the Environmental Ministry and Fukushima Prefecture will also be co-hosting an information exchange and discussion session of experts, and within that session, the Fukushima Medical University's Professor and Dr. Suzuki will be making a presentation. Professor Tsuda will also be making a presentation at that time on 21st of December. So I hope that you would participate if your schedule allows.